so lit right now. Okay, okay, okay. I'm so lit right now.
We're so lit to learn about chemical and physical reactions.
Well, what's the difference between a chemical and physical reaction? Chemical reactions change the form of a substance without changing its chemical identity, while chemical reactions involve the formation of new substances by breaking or forming chemical bonds.
Today we are making chocolate-covered strawberries. First, safety. Second of all, let's go melt that chocolate. Okay, looks like the chocolate's all melted. Melting chocolate is a physical change because the heat from the microwave increases the molecular kinetic energy. This eventually rearranges the molecules from a fixed solid to a more fluid liquid state without changing the chemical composition. Okay, let's put this in the fridge.
This is good. You guys should try it at home.
Chemical reactions are everywhere, even in everyday things like baking. Here I am making brown butter chocolate chip cookies. I sliced up my butter. So first I'm melting my butter. So when you're browning butter, you want to let it simmer until it's golden brown. It adds a richer flavor due to the Maillard reaction. And the Maillard reaction is when water molecules evaporate, leaving the milk solids. And the milk solids then separate and brown, which give brown food its distinctive flavor. Okay, so here I can tell the butter's ready because it's starting to turn golden brown. And there is the separation from the milk solids. So here I'm pouring in my sugars. Okay, so here I added in my eggs and vanilla. Okay, now I'm adding in flour and my baking soda and the salts.
So today I'll be doing the Coke and Mentos experiment. In this chemical reaction, the carbonated Coke reacts with the Mentos and a foam-like substance is produced. This causes extreme pressure inside the bottle and a volcano-like eruption occurs.
Bruh.
Nope.
Huh? Bruh. Bruh.
Huh?
Bruh.
Nope.
Huh? Bruh.
Nope.
Bruh.
Nope.
Huh? Bruh.
Slime. I know you've definitely played with slime before or you even made it, but how does slime actually work? We all know slime is made out of some kind of activator and glue. Slime is a chemical change because when you add glue, which has a chemical called polymer in it, and when you add borate, also known as borax, together in a bowl, the molecules in these chemicals form together, creating chains. These chains link together when you add these two into a bowl and mix it together. The atoms then in this experiment change their arrangement, which causes the liquid glue and liquid activator to turn into a solid slime.
Today we are making elephant toothpaste. What did the dentist say to the elephant about his new toothpaste? It looks like you're having an elephant time brushing. Just don't try this at home. First, safety. And next, we have to do half a cup of hydrogen peroxide. Okay, next, a big squirt of dish soap. 1 tablespoon of yeast and 3 tablespoons of warm water. Elephant toothpaste demonstrates a chemical reaction because the atoms in the hydrogen peroxide decomposes into water and oxygen gas catalyzed by yeast. This causes a rapid production of foam due to the trapped gas in the soap bubbles, showing a change in the substance properties.
So for my physical change, I will be breaking glass. Breaking glass is a physical change because it changes the shape and the size of the glass without altering the chemical composition.
Today I will be melting some crayons on some parchment paper using a blowtorch. This is a physical change because the heating melts the substance so it changes its state of matter. The crayons will start to melt from the heat of the blowtorch, and this will help the crayons molecules start to gain enough kinetic energy to speed up and eventually break their attractions. By the molecules breaking their attractions, they can also break out of their position, causing the crayons to change its state of matter from a solid to a liquid.
キュルキュルキュンキュルキュルキュン素直になれなくてもキュルキュルキュンキュルキュルキュンあたいが世界一くらくりくるくるくれくるみかわいいナンバーワンあたいはくるみまつげもきらり瞳はスイートキャンディー
I have 2 pieces of ice. One is on the blacktop and one is on the concrete. As you can see, the one on the blacktop is melting much faster than the one on the concrete. And if you would touch the concrete and the blacktop would be hotter, so the ice will melt faster. When you touch the blacktop, it's hotter because the black absorbs more sunlight than the concrete. The concrete reflects the sunlight while the blacktop retains it. When the ice is put on these surfaces, the ice changes from its frozen state of ice to its melted state of water, which is also its room temperature state. During this melting process, the atoms speed up and change their physical appearance. The hydrogen atoms that are holding the water molecules together start breaking apart and change into a liquid form. And that's why ice melts faster on blacktop than concrete.
Boom, clap, the molecules and atoms keep moving and on and on and on and boom, clap, it's a physical change, come on to me now. Boom, clap, the atoms keep making bonds and on and on and on and on and boom, clap, it's a chemical change, come on to me now. No changing chemicals could form me a new look. Couldn't make the atoms bond during a chemical change. This shows a rapid production of foam due to...
Hi guys, so for my experiment, I will be breaking glass and breaking glass is a physical change because it changes the shape and size without altering the chemical composition.
Hey guys, we're back with another video, and today, what will we be doing? I don't know.